Hey everyone, welcome back. Today we're going deep on something that can really mess with your MongoDB setup. We're talking about the Linux OOM Killer. And we've got some sources here to help us break it all down.
Yeah, it should be pretty interesting.
So picture this. You're running MongoDB, right? Everything's going smooth, your app is humming along.
Right.
Then suddenly, bam, your database just disappears, vanishes, because the system needs memory somewhere else.
Happens all the time.
That's the kind of nightmare we're trying to help you avoid today.
Absolutely. Nobody wants that.
So what is this killer? What even is that?
Well, you can think of the OOM killer as like a last resort. For the Linux kernel, I mean.
The Linux kernel.
Yeah, when your system is like really low on memory.
Critically low.
Yeah, critically low. The OOM killer, it kind of steps in and it starts,
Deciding who to get rid of.
yeah, basically. It looks at all the processes running, sees how much memory they're using.
But how does it, choose
It gives each process a score based on its memory usage and a few other things.
the score? Huh?
Uh-huh. And the one with the highest score. Well, that's the one that gets
Terminated.
exactly. It's like a what do you call it? A survival of the fittest, but for memory.
Wow. That's intense. But at least there's a record of this, right? Like a digital crime scene?
You got it. It's all logged, usually in the system logs, like in var log messages, so you can always go back and see what went down.
All right. Good to know. So why is MongoDB, our beloved database, so prone to becoming a victim of this OOM killer?
Well, MongoDB, it's built to deal with a lot of data. Big data sets, complex queries, all that.
Right.
And all that takes memory.
So it's kind of like if other processes are, I don't know, sipping from a teacup,
Yeah.
MongoDB is chugging from, like, a gallon jug.
Exactly. That's a good way to put it. And our source material actually digs into 3 specific reasons why MongoDB might be using so much memory.
Okay, yeah, let's hear it.
So first off, it's how MongoDB stores the data.
The format it uses.
Yeah. It's this format called BSON. And BSON, it's great because it's really flexible. You can store all kinds of data types.
Right, that's one of the things people love about MongoDB.
For sure. But that flexibility, it can mean that BSON needs more memory compared to some other database formats that are, a bit more strict.
Makes sense.
And then the second thing, the second memory hog, is indexes.
Indexes, right? Those are essential
Yeah.
for making searches faster.
Exactly. But they also use up RAM. It's like if you have a giant library, right, and you've got this super detailed table of contents,
Uh-huh.
super useful, makes finding things a breeze, but that table of contents, it takes up space.
It does. It does. And the third reason, I'm guessing it has something to do with those complex operations MongoDB is known for.
You nailed it. Things like aggregation pipelines, those large write operations, all that, they can cause these temporary spikes in memory usage. So we know this OOM killer is out there, and we know why MongoDB might be particularly vulnerable. So what can we actually do to protect our database?
Yeah, the million-dollar question. What are our options?
Well, first things first, you gotta know your enemy.
Right, Sun Tzu and all that.
Exactly. You can actually check MongoDB's OM score using this command. Cat pros propdoff mongod score.
Okay, so we run that command, and it gives us a number. What does that number tell us exactly?
It gives you an idea of how likely it is that MongoDB will be the one the OOM killer targets if it has to step in.
So if we see a high score, we should be worried.
Yeah, you might want to take some action.
All right, so let's say we check the score, and we're not feeling too good about it. Can we, manipulate this score? Change it somehow?
We can. There's another command you can use. Echo nacko 1000 propdoff mongod scoreage.
Okay, and what does that do?
It basically makes MongoDB less likely to be killed.
Less likely, so not impossible.
Right. It's important to remember that even though you might be tempted to...
To make it unkillable.
Yeah. But if you make your database unkillable, it can actually destabilize your whole system if something goes wrong. It's a risky move.
Yeah, that sounds like a recipe for disaster.
Hmm.
So what are some, safer options, some long-term solutions that won't, risk crashing the whole system?
Well, if it's possible, adding more RAM is always a good idea.
More RAM, the classic solution.
And when it comes to MongoDB, that means optimizing your queries.
Right, making them more efficient so they don't use as much memory.
Yep. MongoDB actually has this built-in profiler that's really useful for identifying queries that are, really resource intensive.
And what about those alerts? our source mentioned.
Oh, yeah, those are crucial. Setting up monitoring and alerts for MongoDB's memory usage is like having a, I don't know, like a security guard.
Security guard, okay, I like it.
Keeping an eye on things, making sure everything's okay, and if things start to get out of hand, memory usage starts to spike, you get an alert.
So you can address the problem before it becomes a major crisis.
Exactly. It's all about being proactive.
So big takeaway here, folks.
Yeah.
Understanding this whole OM killer thing and then actually taking steps to protect your MongoDB from becoming a victim,
Yeah,
that can save you from a lot of headaches.
absolutely. Data loss, downtime, all that. Nobody wants to deal with that.
Nope. It's
Yeah.
all about being proactive and understanding how your system and your database work together.
Couldn't have said it better myself.
Until next time.
See you then.